Yes. So hello guys. In this video we will be solving problem 2169C from Codeforces Educational Round 184. So let's read the question. The title of the question is range operation. You're given an integer array A of length n. Okay. You can perform the following operation. Choose a range L R such that L and R can be equal and both of these variables should be in the range 1 to n, and replace the value of the elements al plus 1 ar with l plus r. Okay, so we'll be choosing an interval and replacing it with l plus r. That's it. Your task is to calculate the maximum possible total array sum if you can perform the aforementioned operation at most once. Okay, at most once means that I can use it either 0 times or 1 time. Yeah, the input seems pretty standard: P, N, and AI. Uh, AI ranges from 0 to 2n. Okay, and yes, the sum of n overall test cases doesn't exceed 2 into 2 raised to 10 raised to the power 5. Okay, we need a solution which should be of time complexity big of n log n or big of n. Yeah. For each test case, print a single integer, the maximum possible total array sum if you can perform aforementioned operation at most once. We'll just try run for the first test case and then we'll get into the solution. The first test case is 251. Yeah. The first test case is 251. Indices are 1, 2, 3, and we can choose any L comma R and replace that specific range with L plus R. So the one naive solution which I can think of is we'll first fix L, then we will iterate through all the possible values of R, and we will do this for each and every L. So this solution will be big of n square, but this is not possible. But let's go through this, this kind of thinking. We will just try run this process. So 2 can be replaced with, we will just use L equal to 1 and R equal to 1. So 2 can be replaced with 1 or 2 itself, and it doesn't make any difference. But we can keep L equal to 1 and R equal to 2. So yes, we have to replace the elements 2 comma 5 with 3. So yes, here we will have 3 and 3, but as you can see it is decreasing the actual total array sum by 1. So this is also not of help. Then we can keep L equal to 1 and R equal to 3, and yes, as you can see, we have to replace each and every element with 3 plus 1, that is 4. So the actual total array sum is 5 plus 2 7 plus 1 8, and this array sum is 12. So yeah, this can be a candidate for our solution. Uh, then we can keep only two. Just a second, guys. Yeah. So we can keep L as 2 and R as 2. So we have to replace 5 with 4, but this is not of help. Then we have yet another possibility where we can keep L equal to 2 and R equal to 3. So we have to replace both of these elements by 3 plus 2, that is 5. And in this situation, um, just a second, yeah. In this situation, the total array sum is 5 plus 5, 10, 12. Yeah, so this is also one of the candidate solution. One last option we have, that is L equal to 3 and R equal to 3. So we can replace this with 6. And yes, 6 plus 5 is um, 11, plus 2 is 13. So out of the candidate solutions which we have, 12 comma 12 comma 13, we'll pick the maximum one. So yeah, 13 is the answer. uh, but if you dry run for each and every test case, you will realize that there is not a specific pattern, and this type of question altogether is a different pattern in itself. If you haven't seen such pattern beforehand, then it is actually pretty difficult to come up with such a solution which I'm going to discuss now. So yeah, whenever you have questions which are like replace a specific interval L comma R with, let's say, this, and the replacement which we are doing is also in terms of L comma R. You know what I mean? What we are specifically doing is we are choosing a specific interval and we are replacing uh, it with L plus R. Yeah. So what will be the difference? Uh, what is the difference which we are creating by performing this operation? And the answer is uh, there will be a we will keep a prefix sum. Yeah. So yeah, initially these elements are al plus 1 dot 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 ar. So we are replacing this with uh, L plus R, L plus R dot 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 L plus R for R minus L plus 1 times. So the difference which we are creating by performing this operation is actually R minus L plus 1, the frequency or the size of the interval, into L plus R, as we are replacing each with L plus R, minus AL in bracket AL plus 1 dot 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 AR. Yeah, let's try to simplify this a bit. This can be represented in a prefix sum array. Yeah, L plus R. Yeah, we will add and subtract A1 plus A2 dot 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 AL minus 1. We already have AL plus AL plus 1 dot 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 AR, and we will subtract the extra elements which we have inserted, A1 minus A2 dot 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 AL minus 1, isn't it? I will erase this bracket. This bracket should be over here. So this expression should be as it is, and we'll try to simplify this. Uh, let's say sk equal to a1 plus a2 dot 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 ak. Yeah, prefix sum. So yes, minus this whole will be sr, and this will be s of l minus 1. So yes, s of r minus s of l minus 1. Are you getting it, guys? This step is pretty important. And now we will try to simplify this term, r minus l plus 1 into l plus r minus sr plus minus minus plus sl minus 1. Let's multiply l with all of the variables in this bracket. So L into R minus L square plus L, and then we'll do the same for R into R square plus LR plus R minus SR plus S of L minus 1. Here we have plus L, yes, here I have made a mistake. Plus R into plus R into minus L is actually minus LR. So here we have plus LR and here we have negative LR. So it will cancel. It will be cancelled. And so let's group together the uh, terms which are in the variable R and the terms which are in the variable L. So here we have R square by rearranging the terms plus R minus SR minus L square plus L plus S of L minus 1. Um, I know this is actually difficult to spot first time, but as you can see, there's a specific pattern over here. So here we have R square, here we have R and R. So all of these terms are, in terms of R. And here, as we can see, here we have S of L minus 1. So here we would like to create L minus 1 ka whole square. Yeah. So let's do this. R square plus R. Yeah. Basically, we are trying to create, or we are trying to, decompose this condition into two functions. This is the pattern. And many problems based on this are actually on lead code as well, which are relatively easy. If you have solved those questions, then this question will be comparatively easier. So yeah, L square, we will add, um, yeah, we will subtract minus 2L, not minus 2L, we will keep this in a separate bracket. So L square minus L minus S of L minus 1, as we are keeping them in a bracket. Then we will minus S of R. As we are trying to create L minus 1 ka whole square, we will write L minus 1 whole square minus L minus 1 whole square plus L square. Oh shit. Let me reopen this again. Restart file. Yeah. Just a second. Yeah. So here we are adding and subtracting L minus 1 whole square plus L square minus L minus S of L minus 1. Yeah. Uh, let's open this bracket itself. So we will have R square plus R minus S of R in bracket L minus 1 whole square minus in bracket L square minus 2L plus 1 plus L square minus L minus S of L minus 1. R square plus R minus SR, um, in bracket L minus 1 whole square. Now we'll open this bracket. So minus L square plus 2L minus 1, yeah, minus L minus S of L minus 1. So L square and yeah, I forgot to write one more minus L square term over here. L square and L square cancel. 2L minus L is L. So we have transformed our, given operation in uh, two variables, L comma R, such that uh, our operation is causing a difference of R square plus R minus SR minus in bracket L minus 1 whole square plus L minus 1, yeah, minus S of L minus 1. So as you can see, can you see that there is a similarity between these two brackets? As you can see, the expression in terms of R is R square plus R minus SR. So if we say let fx be x square plus x minus sx, so we can say that the difference caused by our operation can be f of r minus f of L minus 1. Why? Because substitute r in this function, so r square plus r minus sr. Yes, here is our expression, and substitute L minus 1 with x, so L minus 1 whole square plus L minus 1 minus S of L minus 1. So yes, now as we know that L should be smaller than or equal to R, this question is, this question has gotten pretty simple. You may ask how? Because we have to just find, we will have a prefix minimum. We will not create an array, but we will have an instant minimum, and we will compare this minimum with each and every f of r, and we will try to maximize f of r minus f of L minus 1. So as you have noticed that we have decomposed this condition into a mathematical expression, and we have to just maximize this. So this is pretty easy, because because both of these functions can be calculated independently and are actually independent of each other, isn't it? So let's get into code. The question number is 2169C, and yes, yeah. So first of all, I'm taking the input of array, and I'm creating and assigning the values of prefix sum then and there itself. Then I'm writing a maximum increment function. Let's read this maximum increment. So yes, I know that the name of the variables are too straightforward, but it helps me understand what is going on pretty neatly. So yes, we have to calculate, um, as you can see, f of L minus 1. As you can see, I have created a variable LL minimum of f of L minus 1, which is initially equal to fx of prefix sum comma 0. Why 0? Because the first index is 1, and L minus, and we are trying to compute f of L minus 1, so f of 1 minus 1, that is 0. And this fx function takes the parameter of prefix sum and x, where x is the index, and it just simply represents, it simply returns x into x plus x minus prefix sum of x. As we have declared, um, Sx is equals to a of 1 plus a of 2 plus a of 3 dot 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 a of x, and prefix sum is exactly the same. What is prefix sum of x? It is a1 plus a2 plus a3 dot 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 ax. Yeah. So here we are initializing minimum of f of L minus 1, and yeah, we have another variable LL of maximum increment, which is initially 0, and we have to maximize this variable. Then we'll start our iteration from 1, and then we'll go on till n. First of all, we will not calculate f of r then and there itself. We will first calculate if the given index I uh, helps us find Yet another minimum f of L minus 1. But you may ask, can I use the same index I for L and R? And the answer is yes. Why? Because L and R can be equal as mentioned in the question. Uh, Let me show you. L is smaller than equal to R. So L and R can be equal. So first of all, we will check if f of I f of I minus 1 gives us our minimum of f of L minus 1, and then we'll simply use the value which is smaller. So m minimum of f of L minus 1 is equals to minimum of f of L minus 1 and fx of prefix sum fx of I minus 1. Yeah. Then we'll calculate fr, and as we have f of r and f of L minus 1, we can calculate the uh, difference caused by this operation, and we will record this operation in maximum increment. If maximum increment is smaller than this difference which is being created, then we'll simply assign f of r minus f of L minus 1 to maximum increment. After the iteration, we will have our maximum increment possible, and we are simply um, we are simply printing prefix sum of n plus the in maximum increment which we have got uh, from the function. What is prefix sum of n? It is a of 1 plus a of 2 dot a n, which simply represents the initial value of total array sum. And as we have incremented uh, through this operation, let's say we got maximum increment as 3, and initial total array sum was, let's say, 6. So 6 plus 3 will be 9. So yes, the new array which will be formed will have the total array sum as 6 plus 3, or prefix sum of n plus max increment as its new total array sum. So let's submit this code to 169. Yeah, let's copy. Yeah, and let's submit. You already submitted the same code before. Okay. Yeah, this is f of x. I'm just creating some difference. Taking input for t, and let's check. Yeah, we got an AC. So as you can see, I had tried this question in the morning, but I had made two mistakes. The first mistake was sign integer overflow. I thought that the prefix maximum, the prefix sum won't cross the integer range, but it did. So yeah, that was my mistake. And another mistake I made was that initially uh, I was thinking in terms of zero-based indexing, but as you can see in the question, the array is described in one-based indexing. So don't make this kind of mistake, because even though your logic is completely fine, just because you're using some different based indexing, your answer or your resultant answer will be completely different, even though there would be some logical difference, a minimal mistake it is, but in context it hurts. So yeah, I hope that you have understood this question, and in the next question, in the next video, we will be solving 2183C. Thank you.